Assalamualaikum and hi everybody. We from Group 22 will be presenting the topic of evolutionary AI strategy in video games. First of all, I will introduce the team members. The first one is myself, Hatim. The second one is ADLINA and the last one is HANIS. And so moving on to the introduction. The evolutionary neural network, or ENN for short, is a hybrid approach that uses neural network and evolutionary principles like natural selection and mutation. ENN can change AI behavior by changing the neural structure and weight to get the intended outcome by the researcher. By using ENN in AI, it will make the AI have the ability to make more complex and human-like decisions, as it will imitate how the human think to come out with a solution or decision.
Hi, my name is HANIS. So today I'm going to explain more about problem statement and problem solution of evolutionary AI in video games, AI strategy in video games. Nowadays, players demand smarter and human-like opponents that can adapt to the different gameplay styles. The existing AI system in video games lack the capability to learn and evolve strategies autonomously. The traditional AI approach does not meet the player's satisfaction due to predictable games pattern and repetitive behaviors of AI is unable to adapt in real time to player strategy, also make a struggle for game developer to balance gameplay difficulty and cater to different skill levels. Solution that we can provide for this problem stated is the adaptive learning machine that evolved the AI for testing different strategies. The second problem solution that we can provide is behavior optimization of AI that enable AI to select the most effective strategies. Next is dynamic difficulty adjustment (DDA), where AI can adjust difficulty level based on the player's skill level. And last solution that we can provide is real-time strategist evolution, where evolutionary AI can adapt with gameplay tactics in real time by countering player strategies.
Moving on to the methodology part of the study, the method that we will discuss is real-time neuroevolution of augmenting topologies, or RTNIT for short, that use a game that was built from the ground up called Nero to test the method. The main idea behind it is complexification, in which the network will start simple and by time or generation, more nodes and connections will be added as the AI behavior become more complex. The three key main idea of which NEAT method is based on is first, the chain will be tracked when the complexity is increased over generation. A historical marking number will be assigned to each gene corresponding to its order of appearance over the course of the evolution. This was done because if the gene is not kept track, it will be unclear in later generation how their genes should be combined to produce an offspring. Secondly, individuals will be grouped and they will compete primarily in their own group instead with the population at large. This is to protect and give time for any innovation to optimize the structure before competing with other individuals in other groupings. And lastly, new structure will be introduced as structural mutation occur, and those structures that survive are found to be useful through fitness evaluation.
So for the result and the discussion, the AI could evaluate and modify its behavior in real time by combining evolutionary methods with reinforcement learning. Because of this skill, it was able to successfully counter both experienced and seasoned play strategies, increasing the difficulty and appeal of the gameplay. The AI performed conventional rule-based system in terms of performance, demonstrating its superior decision-making skills with a noticeably greater win rate. By using a bigger range of methods, it also increased gameplay diversity, which decreased predictability and improved player engagement. So by using a bigger range of methods, it also increased gameplay diversity, which decreased predictability and improved player engagement. The development of AI in video games benefit from evolutionary approaches in a number of ways. Among the prominent is dynamic adaptation, in which the AI continuously evolves by imitating natural selection, which guarantees that even during parallel gameplay sessions where strategies may change over time, the AI stays competitive and relevant. The development of AI in video games benefit from evolutionary approaches in a number of ways. Among the prominent is dynamic adaptation, in which the AI continuously evolves by imitating natural selection, which guarantees that even during parallel gameplay sessions where strategies may change over time, the AI stays competitive and relevant. So for the figures and illustration, mutation is a genetic operator used to maintain genetic diversity of the chromosome of a population of an evolutionary algorithm (EA), including genetic algorithms in particular. So for the crossover can be difficult to implement in a reasonable way since the two individuals may be widely different. One way of avoiding this problem is by implementing markers of some kind which identify analog section of each individual so they can be interchanged more easily. So there is an example of mutation in this page.
This figure illustrates the evolutionary neural networks (ENN) process that is typically used in AI systems such as in video games. There is 7 steps in ENN, which first we start with initialize population of strategies on neural network weights. Second one is evaluate each strategy solution in game environment. Next, we select the best performance strategy based on fitness score. Cross over two or more strategies to create new simulating genetic recombination. Step 5. Apply mutation to some offspring to introduce variability. Loop back to evaluation until it gets the optional solution is found. And the last one is select one AI strategy that meets the desired criteria.
In conclusion, the use of ENN in video games for AI is a significant advancement in the gaming industry. By using the combination of neural network and evolutionary principle, it enables game developer to meet an AI of complex behavior. Other than that, it also enables AI to adapt dynamically in real time based on its environment and input, which ultimately making the AI have a human-like behavior.